For number 7, we are given a graph that looks like this. It says that a projectile is fired at a time of t equals 0. And that from the point 0 at the edge of a cliff, the initial velocity components are v of x. V initial of x is 30 meters per second, and v initial of y is 100 meters per second. And that it rises and falls into the sea at point P, and the time of the flight of the projectile is 25 seconds. Now, the first step I got wrong was I thought that this 25 seconds, the flight time, was going to be essential to me solving this equation. Watching the video, I now understand that I didn't need this at all. So first, we can look at the displacement for v initial of x, 30 meters per second. And we know that velocity equals x, the change in x, over the change in time. Now, we are given the velocity and we want to find how far we've gone. So we're going to write the change of x equals velocity times time. So the change in x will equal our velocity in x, our initial velocity in x, 30 times t. So the velocity of x is always constant. It is always 30. However, the Vy is changing. Vy is changing 100 meters per second plus the acceleration times time. We know that gravity equals negative 9.8. So we can plug in 100 meters per second plus negative 9.8 times t. The question asks the magnitude of the velocity at time at t equals 15. So we can plug in 15 seconds to our equations. Now we know that Vx 30, it's going to stay at 30 because that is our constant. And that our Vy, we can plug in 15 for our t, and that would give us 100 minus 147, and Vy equals negative 47. With these two values, we can find the magnitude of v, because the magnitude of v is x squared plus y squared, and now we have our x and we have our y. So the magnitude of v equals 30 squared plus negative 47 squared. And the magnitude of v equals 900 plus 2209. And our answer equals 55.75, which rounds up to 56. And that is our answer, 56, option A.